Hello everyone, welcome to this video by Data Science. So we will continue our course on Python. So far we have discussed all the data structures, we have discussed loops, we have discussed list comprehension, dictionary comprehension, and you have been solving few assignments, quizzes and all that. So you would have seen, I know you guys are still struggling because these are just the earlier days. So I will suggest that keep on practicing unless you have actually explored 200 to 300 questions. Don't start judging before that okay, I'm not able to understand Python programming, because Python is a way complex language than SQL. Okay, and unless you have explored, ask yourself honestly, have you attempted at least 200 to 300 questions? If you have not attempted that, then don't judge yourself that no, Python is difficult, I'm not good at Python, or those kind of things. Because right now there is too much inflow of knowledge which I'm providing. Like every day I'm giving you a new video or a new topic and new assignment. So for a lot of you this might be a new setup, right? And to input this level of information, so much information in a human mind, if you take, it's not possible that you grasp everything and then you start solving as well. So it will take time. So there is no, as I always say, there is no shortcut to programming. You have to spend 4 months, 5 months, 6 months. But my motive behind this course is that you guys can understand what all things are there, and you build some information, you build some base on Python, so that even after this course is finished, you yourself know what I need to do next. You don't need any course after this particular Python course once you have attempted this. Okay, so we will start a discussion. This video is on our first. So we'll start our DSA. Basically, DSA stands for data structure and algorithms. So data structures, we have covered most of the data structures which are mainly required for us. And now we will start the algorithm part. There are 6 to 7 algorithms that we will be covering, which are mainly required for data analyst or data scientist. So in this video, we will start with linear search. But before moving to linear search, I will just like to talk about couple of topics because I have not yet created videos on them, but you might need some understanding of those because I'll be using them in this video. So you don't need to master them, but just understand what are they. The first thing that I want to tell you is Python function. What is a Python function? So don't worry, I'll create a full-fledged video on Python function. What are the properties? Just like I create for anything. What are the properties? What are errors? What are arrays, calls? Those kind of things I'll create. But here, just try to understand the basic intuition of a function because I'll be using. So like for example, so far we have been writing down codes here that, okay, let's say I write down a code. So let me open this Python workbook, for example. So let's say so far we have been writing down code. Let's say there is a number a equal to 2 and b equal to 3. I want to sum them. So what I do c equal to a plus b, and I'll do a print of c. Okay, if I do print c, it will give me 5. But the thing is that this code is static, right? Let's say I want to change these numbers dynamically, and I want this code to print automatically. I want to create a universal thing. So their functions are used. Functions are basically they execute your coding. Nothing changes. Functions are just ways to automate your code flow, right? So they're just whatever coding that you have been doing, it will remain same. It will just that you will wrap it inside a function. You will wrap it inside a function. Rest all remain same. So code is your backend, function you can say front end or outlook of it. Okay, so that's all we need to know. So how to define a function? For example, let's say if I have to convert this into a function. So a function is defined as using keyword def. Def means definition. Then you have to give a function name. A function name, for example, we can give it any. Let's say sum, and then there is a bracket. In bracket, you need to provide the input parameters. So what are the input parameters for me in this particular scenario? They are a and b. So I'll pass, there will be two input parameters, a and b. Okay. After this, my coding will start. whatever I do, let's say, so what I'm doing c equal to a plus b, and then instead of print, what we use in function, we always have, so function takes input parameters 2 and it returns something. So it return, and what you return c. Okay, and now if you do, let's say, sum, so now I run the function. Now I will do sum. So let's say I pass any two numbers, let's say 4 and 9. Okay, and it will create a value 13 for me. So we have created a function like this and it will be used. So what does the function do? That it is a block, basically it is a code block. Okay, it is a code block inside a wrapper, and what happens that you provide input parameters, you provide parameters to a function. Okay, and it returns you some value, it gives you some output. Okay, so these two are the important things. These two are like, first is parameter and return keyword is very important. So what is the syntax? It is def, then function name. Okay, this you can name it, then in the bracket you need to provide parameter can be anything, it can be any number of elements. Then you close this, then you write your code block. Okay, code block, and in the end it is mandatory to return a function, return something. So whatever you are doing, you have to return something through this function, and this is the just the syntax of a function. I'm not going beyond this because I will be covering function in very much detail. So but I just want you to know the def, function name, and then there is a return. What are you returning? Technically function is nothing, whatever code, for example, let's say we are doing I just explained you that we have been summing these two elements earlier as well. We will still use the same, the logic is same, it is just that we have wrapped our whole code inside a function. That's the only difference. Okay, so your coding, nothing changes, because this function is required at times when you will be writing things on our coder pad, like the coder pad that we have built on data science website, and also the when you do this linear search data structure algorithm, you need to know the functions a little bit. So that's why I just gave you a basic idea. So just follow along. You don't need to worry if you don't understand it properly. We'll cover them extensively in a video very soon. So after functions, we need to know two more things. I have already created a video on this, but I need to create one full detailed video on time complexity and space complexity. So in this video, I just understand what do they mean and where they are how they are used. We will cover them extensively in future video. Space complexity. Okay, so what happens that whenever you write a Python code, okay, point is, if you have to be efficient programmers. So let us say you have a block of code. Okay, this is your code. How it is, there are two parameters to this to call a code effective. First of all, how much time it takes to run, and second is how much space it requires, like during the code. How efficient is your code depends upon how many variable declarations have you done, how many new data structures you have created, how much space you required for running this particular code, and all this. An ideal scenario, you want minimum time and minimum space. These both should be minimum for the ideal case. Now for some cases they can be minimum, for some cases they cannot be. So explaining what is time complexity and space complexity. Time complexity means that does the runtime, time complexity is dependent upon the runtime of your code. Does the runtime of your code depend upon the input parameter? For example, let us say, I think I've already given this example. Let us say you are chopping of vegetables. Okay, so let us say you have a list of vegetables that you need to chop. Okay, so let us say you have vegetable, let's say you have carrot, and after carrot, let's say you have cauliflower. Okay, and then you have another vegetable 3, vegetable 4, and so on. Okay, this is your vegetables list. Okay, what is your this code. So every code does some activity, right? It does some activity. So what is the activity that you need to achieve through your code? You need to basically chop these vegetables. Okay, now let us assume each vegetable takes 1 minute to chop. So if you see, as the length of your input, as the length of your input array increases, means as the number of elements inside this increases, your time to run the whole code also increases. It means that time to run your code is dependent upon the size of the input parameter, size of the input input array or text or whatever you say. So here it varies linearly because all the things take same time. So for example, if there is one, if there is one vegetable, it will take 1 minute. There is two, then it will take 2 minutes. If there is three, it will take 3 minutes, and so on. So this is called time complexity of ON. This is linear time complexity. Okay, so just understand this much, that what is time complex. There are other as well, O n square, O log n. You can watch the full video on our channel, which is already present, but I will create. So the intuition behind time complexity is this only. Now coming to the space complexity. Now whenever you run a code, there is a memory allocated in some server, right? You cannot run anywhere. So what happens that the space complexity, okay, if you are if you're defining a new data structure inside your code. For example, let's say you're running a Python code. Inside that you created, you got an input. Let's say you got an input array. Let's say you got an input array. Let's say you got an array 1 2 3. Okay, and you have to do some operation on it. To create this, you created another, let's say you created a final array or you created a final list. Okay, you created this new data structure which will store the values whatever you are creating. So because you're creating a new element, this will increase the space. It will increase the space that is required inside the program, right? This is called space complexity. This is generally ON, but it keeps on varying. I mean, depending, just like time complexity, your space complexity also increases. So overall, time complexity and space complexity are nothing. They are just time and space required to run a code, and how it varies depending upon the type of code you are running. And that comes under code optimization. When you do code optimization, okay, what you have to do, you have to write a code in such a way that your space is reduced, your time is minimum as possible. Okay, so this is all I wanted to speak about. You can watch the video, I'm saying again, on our channel already present. Otherwise, I'll create a full detailed video on this, on how to generate time complexity and those kind of things. So yeah, now I'll move forward to our topic. So the first algorithm that we are going to discuss is linear search. Linear search. This is a very important algorithm, very basic one. This is the whole intuition. This is your base. If you don't understand linear search well, you will not be able to understand other algorithm, because they all are just add-ons to this, or maybe they use linear search somehow in some place. The algorithm is very simple. I mean, if you just relate to your daily life. For example, let us say you have gone to a mall to buy some clothes for you. Okay, you have to buy an ideal shirt. Now what happens that there are 11, let's say there are 10 shirts present in the mall. Okay, there are 10 shirts. So let's say this is shirt 1, shirt 2, shirt 3, shirt 4, 5, 6, 7, 8, 9 and 10. Okay, so you know that you have to pick only one shirt. So the moment you have to pick only right now you have to pick only one shirt. Okay, for example, or let's say you want to, okay, so let's say you want to pick one shirt. Okay, only one shirt. You want to decide whether this is good for me, whether you'll purchase it or not. So what you generally do, you start from 0. Okay, you start from here, you go to the first shirt. Okay, you will wear it, you will check in front of a mirror, click some selfies and check, does it look good, yes or no. Suppose you don't find it good. Okay, So now what you do, you now go to the second one. Now you check yes or no, something like this. Similarly, you keep on progressing. You keep on checking one by one. Each of the shirts you are checking one by one, and somehow at this position you see your shirt which seems perfect for you, and you decide that this is I'll buy this particular shirt. So what is this? This is called linear search. That you have a list of you have a list of elements, or you have an array of elements. You have to find a particular. So basically you have to search something. You have to search something. Okay. So how do you do? Most basic method anyone will do that. Okay, you have 10 shirts, and you have 10 shirts, and you have to identify whether, let's say you have a list of 10 numbers. Okay, you have a list of 10 numbers, and you want to identify, you want to check whether a number is present in that particular list or not. So what you do, you check one by one, you keep on checking if that number is present or not. And if you find it, then you are good. If you do not, once you reach at the end of the array, if you do not find it, you say, okay, my search was unsuccessful. I didn't find my number or the shirt that I was looking for. This is the linear search. The main concept is you go one by one. You search everything one by one. And can you tell me what will happen, the time complexity of this? So see, if your number of shirts increases, basically the size of your input array if increases, your time will also increase, right? So with n, the length increases, time also increases. Okay, so linear search is always of the time complexity on. On means linear, that as your it increases proportionally. So let's say it takes 1 second, take 1 second, 1 second, 1 second, and so on. So like for example, if there are 5 elements, it will take 5 seconds. If there are 10 elements, it will take 10 seconds, right? So this is a linear line. If you draw this, let's say this is the time, and this is the number of elements. If you draw a line for a linear search, time complexity, it will look like this. This is on. This is called on. We'll talk this in detail, but just try to understand how this particular algorithm functions. Okay, now we'll go to the our booklet. So let's read about it. It say the linear search, also known as sequential search, is the simplest algorithm used in computer science. It checks each element in the list sequentially until the desired element is found or the list. So there are two things. Either you find the element or your list ends. So when does your search stop? Your search stops when either you find, let's say, when you find your element, or you reach the end of the list second, right? So your search ends with either of these methods. Now the intuition behind this is straightforward. Start at the beginning of a list and check each element one by one until you find a target element. So you have a target element and you have to find it. If you can reach the end list without finding the target, it means the element is not present. Okay, so as simple, you are given a question that this is a list, please check if this particular element is present in that or not. So what you will do, you will start from the start and you will check each element one by one. For example, let's say this is an array 2 4 2, so this is an array 2 4 6 8 10, and this is your target value. You want to check whether this value is present in this or not. So you will start from here. First you will check with 2. Is 2 equal to 8? No. So you will move ahead. Is 4 equal to 8? No. Is 6 equal to 8? No. Is 8 equal to 8? Yes. You found the search, and what you have to do, you have to return the index. So the question says that searching for an element and return its index. We'll solve this question through a function just in a while, but this is the overall architecture. I will say that how does a linear search works. So let us take this question, right, that we have an array and we have a target element. So let's try to understand how to use linear search here. So let's say we have an array. So let's say this is the array. This is equal to 2 4 6 8 10. We are given an array, and we know there is a value target. Okay, this is a value target. So target is equal to, let's say here it is equal to 8. I want to check whether this element, I want to write down a code to check at which index is this present inside in this particular So if it first I need to check if it is present, yes or no. I want to know this, okay? And if it is present, I want to know the index of it, the index. So what is index? Index, for example, this is 0, this is 1, this is 2, this is 3, this is 4. So at which index or position is that particular target is lying inside my array? So that is my objective of this linear search. So what I will do, first of all, we will see a simple thing that we have to write down for. We use a for loop for this, okay? For, let's say I. Now what happens that for I in range, now I'm using range here, okay? Why I'm not using directly the value? Because I need to provide the index. So that's why I'm using the range here, okay? So if I just wanted to check if a number is present, I can simply so there are two things. For example, let's say if I just wanted to check whether a number is present or not, so let's say this is ARR is equal to 2, 4, 6, 8 and 10, okay? And I have the target value. I have the target value equal to 10. If I just want to check, let's say it is 8. I just want to check for element in array. If element is equal to 8, okay, if element is equal to 8, what do I need to do? I need to print let's use f string literals. So the target value 8 is present in array, okay? Else I will print target value is not present in array. So I'll just copy this, and target value is not present in array, okay? So after this, now if I run this, so what is happening right now, it is checking for each of the elements. So basically for element for the first element, it is checking is 2 present, no, so it is present, it is printing this 8. For is 4 present, no, 6, 8 is present, so it is printing if target value 8 is present in the array. So that's how the result is printing, okay? This is how we check if something is present inside this loop or not. So it's a very straightforward question, coding question. So that's what we have been doing here for I in range, and we just check. Now the next thing comes, what if I want to know the index? Okay, I just don't, if an element is present, I want to know the index. So through just element I cannot get the index. I need to use range. So that's why we use range. Now range will vary. Now this array will have a length, okay? So let's use the length of array. So what is the length of array? There are 1, 2, 3, 4, 5 elements. Length of array is, so technically it will become range 5, means it will vary from 0, 1, 2, 3, 4. That's how it is going to vary, and that's what we need for I in now what we do, if ARR of I is equal to 8, okay, if it is equal to 8, then we need to print that target is present at particular I location, okay? And that's how we will do. Otherwise we will say it is not present. So if we just want to retrieve the location, we use that particular. So what we need to change here, for I in range, length of ARR, okay? Now what I need to change, now I cannot directly call element. I need to call any element by index. So what I will do, ARR I, if this is equal to 8, so the target value 8 is present at index Now you will provide the value I. Else you will say it is not present in the array. So see, we got the result. The target value 8 is present in the at index 3. So that's how we generated this particular code. So far in the like we saw that we basically how do we do a linear search is that we get an array and we scan to each of the element one by one by using for I in range of this, and if an element is present we will print it, otherwise we will skip it. So that's how what we have been doing. Now let's try to build this function on our own from scratch, right? So what do we have here? We have to build a function that takes an input array, okay, that takes an input array and a target value. You provide it as an input input array and a target value. If target is present in array, return its index, otherwise return -1. So for example, let's say I have an index, I have a target array this, target this, and array this. I want to scan an 8 in this, and if 8 is present, return its index that like 0, 1, 2, 3. Otherwise, return the return -1. So that's what we have been doing. So let's start using building the function as well, because we will need the use of function later on, because we don't just want to test on a single element. We want to create a generic thing so that whenever we pass an array to that particular function, we can get the result, right? So so that is our objective. So let's do one thing, how to write a function. Let's do it's using the def keyword. Def, let's say now target search. This is my function, and what do? It takes two parameters. The parameter 1 that it is taking is the array, and the parameter 2 is taking is the target value. So this is how you have defined the function till now. So you have it. Now what will happen through this target search? You pass any array and you pass any target value, it will be able to give you a generic answer. Otherwise, for let's say if I write code for this specific scenario, now the moment I change a, it will not reflect in my code. Moment I change target, it will not reflect, because I have been comparing like this. If ARR I is equal to 8, right? I was using like this, but I want to make a generic code which works everywhere. So that's why so basically these functions are utilized everywhere. So once you create this function, now you can use anywhere. For any array you pass, you will get its index. So how do we do? So we start with for I in range, let's say range length of array. Okay, so we will pass. So for example, let's say this is the array. So it will be 0, 1, 2, 3, 4. So it will go through one by one, first to 0, then to 1, then to 2, then to 3, then to 4. Okay, so this is what it will be doing. Now after this for loop, I need to check that if ARR I of this that is the element of array at this index, is it equal to my target? So see, I am not passing any constant value. I'm using the target variable, so that whenever user changes this target value, my function will automatically take it. If ARR is equal to target, what do I need to do? So if there is a match, I should get the index of it. So return I, right? For example, so let's say I'm here, ARR 0 is equal to 2, so it does not match. ARR, so let me show you how it is going to work here. So let's say you have this array, right? So you have this array. So you have 2, 4, 6, 8, 10. So what are we doing here? That ARR 0, ARR 1, ARR 2, ARR 3, and ARR 4. So that's what we will be searching one by one, right? So in binary, when we use for loop, it will search. So first of all, it will check this is equal to 2. Is this equal to 8? My target, no. Okay. This is equal to 4. Is this equal to 8? No. This is equal to 6. Is this equal to 8? No. This is equal to 8. Is this equal to 8? Yes. Okay. And similarly, this is equal to 10. Is this equal to 8? No. So whenever I encounter a true, it says whenever you encounter a true, return it. So what I need to return? Its index. So what is its index? I's value is 3 here. So it will return 3. Okay. So that's what I'm doing in my code, that whenever there is a match, return me I. So if ARR is, the moment it matches a target, return I. Otherwise what I need to, and if I leave this particular code, it will keep on doing it. Now they have additionally asked us to return a -1 here. So what will we do? So let's first of all test this function. Let's see, is it working? Target underscore search. Is this function working? Let me check. So let's use any input array. Let's say this is my input array. Okay, and this is my target value, that is 8. Now if I pass this, it will give me 3, right? It has given me 3. So we got it. Now suppose we let's say change it to, now let's say we change it to 7. Will it give me anything? It is not giving me anything. And I might be thinking, is there something wrong with my code because I'm not getting any value? So for those cases when there is no match, we just return. So for those cases when it is not doing, so we will do else return -1. Okay, so sorry, so else, so once it is, yeah, so this is inside this loop, and once this loop is completed, I'll do a -1. So what is happening, that first of all this loop is running. Okay, for now if it finds, it will return, otherwise it will loop again, loop again, and if it is not able to find for anything, it will come out of the loop and it will return -1. Okay, so that's what is happening. Now if let's try to change this, to 12, this to 14, this to 28, 20, and let's say this is 200, and let's say I want to find the index of 200. So what it will, you can change target, you can play around with this particular thing now. Okay, and if that particular, let's say I change it to 201, because 201 is not present, it will return me -1. So this is the function that we have created. This is our first function based on linear search. So this method is called linear search. And why is it? Because the max thing we are doing, we are going one by one, and we are checking each the element. That's all we are doing in this particular code. So this is how we understood that how to basically create a linear use a linear search to find any element in a list and return the value corresponding to what we ask. So we did if element is not present, if element is present in a list. So far we dealt with the integers. Similarly, things with work on strings as well. So let's say we have an array of strings. You can use the same concept. Let's say you want to check if in this list of strings is cherry present or not. Okay, so you'll create the same function that I created above. Okay, and if element found, return the index. If element not found, return -1. So that's what we have been doing. Now we'll solve 5 basic problems related to linear search. Like 2 to 3 are basic, 1 is medium. So the concept remains same. The linear search is pretty simple. The question says search for an element in an integer list. So what do we have? We have an array and we have a target. We have to just check if it is present, return me the index. So I think we have done a similar question just now, only that we can just pass it into this only. So let's say we take this particular array, okay, and we pass it here in this particular code, and we just pass the value target. Okay, and it will give me 2 because 5 is present at the index 2. So you see element 5 found at index 2. So that's what, so the code is given to you as well. I have just used a break instead of a return, that whenever I find something we can simply provide the index, and I have used f string literal to make the output look more readable. So that's something you can explore on yourself as well. Now similarly there is a similar problem 2 as well. Search for element in a string list. Again you have a string and you have a target. Okay, So what are we doing? You are searching one by one. So for I in this range, again, if you found, break, and again exactly the same thing. Okay, now the question that interests me now is that third question: search for multiple occurrences. What if, let's say, this two, if you see this is the array and this target is present multiple times. Okay, now you want all the list of indices which are present, because by let's say, what if we run right now? Let's see what happens if we run right now. If we use this particular index array here, okay, and I just pass the value 2. Now if you see 2 is present, is index 1, 3 and 5, but what does it return? It returns only 1. It only returns with the first occurrence. The question asks that search for a target integer and print all the indices where the element is found, and if the element is not found, print -1. Okay, so what do we do here? So we will have to make some updates in the inner code. So let's try to solve this particular question. So what do we do? So let's start with the function def, and we have to let's name it multiple search. Okay, multiple search, and my input is ARR and my target it remains target. So what I'm doing here is that I'll create an empty array, which is my final list, which I need to create. Okay, so they have asked me to create a list. Okay, print all the indexes where the element is found. So where do I print it? I'll print in a list form. So you can choose a tuple as well. It's totally up to you. So I do let's say I do occurrence. Let's call it list. Okay, let's call it, this is a blank list that I have just created. Okay, now what I need to do, I will write down for I in range length of array. Oh, that's code remains same. Okay, this part of code remains same. If ARR I is equal to target. Now if we find it the target, so what am I going to do now? Okay, so if I find something, I will do one thing: list dot append. I will append. Remember the append function, how to add an element. So now if I am finding something, I am not just printing the I am just putting it in a list. Okay, append I. Okay, I will do this. So now after this, I will now after this is done, now let me print list. Let's see what comes. So let us say this is my, so let's first run the function. Do we see? Okay, now let's say this is the value that I need to provide. So I will call my function multiple underscore search multiple search, and I need to pass an array. So array was this, and then I have the target value. Okay, now if I do this, okay, because the problem is that a function has to return something. So what do I do in the end? I have to just return list. Okay, so if I just use return list, I will get the list of indexes. So what I run the loop, I run everything, and once I found it, I will return the list. So that's how we do this is the exactly thing which we were doing here. Okay, so we basically we find something, then we append it. Okay, so that's how we can do. Now similarly, we can, if we don't find something, we can simply write down an else. We can write down an else statement that you pass it -1, so that you can try. So this is what the whole syntax, the logic is for I in this range, and if it is present in target, you just append it, and you will, so the you have created an extra variable list. Now if you see in this question, we have created an extra variable, and because of this the space complexity of this particular code will be higher as compared to any other code, because we are introducing another new list, right? So that is something that you need to understand. So we just did the question where how we can print basically multiple occurrences of elements, right? And we can, if there are multiple occurrences of a single element in an array, we can print them. So this is also using binary search. Technically we are doing binary search only, that okay, first go to this, second go to this. Now if you find, store it here. Now if you go to 7, if you find, you okay, cancel it. 2, you found it here, then store it here. You found, no, you found it here, store here. So that this is a binary search, sorry, linear search only, that we are going through from left to most. That's all we need to do. Now let's figure out a couple of more questions. The first is search in mixed data type. So you can anyways, I mean, it's exactly same. You have integer, you have a string, and you just need to find a target. So if array equal to this, then found equal to I, and break the statement. So that is also a method. So I'm not solving this particular. You'll get this booklet. You can practice this question on your own as well. So when you practice, remove this code, remove this solution code, right? And I provided the solution code, but remove the solution code and try to write down the code on yourself. This is a fairly easy question, so that's why I'm not solving. Now come to a good question, that is search for maximum element. So what is there? The question says that let's come here. So you have an array like this, okay? So the question asks you two things. Given a list of integers, find the maximum element and print its index. If list is empty, print -1. So what do we need to do? If the array, in the array, first of all we need to find the maximum element, okay? And if you're able to find the maximum element, you have to print its index. So and this question does not make any sense, because anyways we'll find a maximum value. So -1 is never going to be there, okay? So now let's try to visualize how are we going to the architecture or blueprint, how we going to solve it. So for example, let us say we have array A is equal to, please focus very much on this question, how, because I'm still using linear search only. I'm just going from left to right, but the approach that I take is different. 2, 8, 3, 5, 10. So let's say we have this element 2, 8, 2, 8, 3, 5, 10. Okay, so what do I need to do? I need to find the maximum element. First of all, I need to find the maximum element. If I can get the element, I can get its index. So now point is there are some functions which we can pass max of array, right? But we don't need that. We have to build the algorithm, and this is what is called DSA. In DSA, you don't use any function, you don't use any method, right? Function methods you don't use. You try to build everything from scratch with the least information that is present with you, okay? So we are not going to make use of any library. We are not going to use any, I will say, any method or any other function. I'm not going to use any other thing. I have to build everything from scratch, okay? So this thing we are not going to use. So how do we do that? So one basic good approach to this is that we start from the left anyways, right? So what we do, that we initialize something. We say that, let's say the maximum element is my first element only, okay? So what we do is we break this list into two, basically in two halves. So this is, I say that let's say my first, let's say assume element 1. So I equal to, so basically assume element 1 is max, okay? Assume element 1 is max. If you know that element 1 is maximum, then you know that any other number that comes after it will be less than it. Agreed? Now point is that this is fairly true when element 1 is maximum. But what if my assumption is wrong? What if my assumption is wrong, that because here element 1 is not maximum? So what I will do, I will start my linear search into this particular list, okay? So I will I'll store this basically, like just we do pop out, or we basically store this value. Okay, assume this to be the maximum value, and I will start my linear search in this particular list. Okay, if I found, so one by one I will go. If I find any element which is greater than this, I will mark that as maximum temporarily. Okay, so now when I move from this, now this is maximum. Okay, now I go to the right. No, I cannot find. So still 8 is maximum. Still 8 is maximum. But when I reach here, this 10 is greater than 8. So then this becomes maximum. So that's how we update the value of X. So what are we doing? So let's say we have this list again, 1, 2, 4, 10, 6. Okay. What is my first step? Take the assume maximum element. So maximum is equal to, let's say this is ARR is equal to ARR of 0. Okay, we have assumed that this is the maximum of element. Now we will do a linear search in this, and from left to right I will keep on checking if there is any element is 2 greater than 1. Okay, so it is true. If it is true, then 2 becomes temporarily the maximum value. Now I move here. So when I am at this point, what is my maximum value? My maximum value is 2. Now this is when I am at 2. Now when I come to 4, what is my maximum value? My maximum value will become 4. Okay. Now when I come to 10, my maximum value will become 10. And when I come to 6, my maximum value still remain 10, because 6 is less than 10. And overall we see that my maximum value is 10, and then I will print the index of 10. That is the architecture. That is the architecture of this particular question. So now let's start coding the particular solution. So what we do here, so let us say we have this array. Okay, we define a maximum value. Let's say maximum value, let's say max value is equal to ARR 0. Okay, I have defined max value, right? This is a temporary, or you can say temporary max value. Okay, you can say temporary max value. We call just temporary max, that is AR0, and temporary underscore max underscore index. So what is the index of this? This is the index is 0 right now, because I'm keeping this as my my maximum index. Now what I will do, for I in range, now comes the main part. Now I am starting my linear search not in this. Okay, I'm starting my linear search in this particular array. So what I will do, but I cannot change the structure of array, so I will start, my range will start from 1, not from 0, and it will go till length of ARR. Okay, so this is the first point that you need to know. You have to mention this one, because because I have already assumed 2 is maximum, so I'm starting my search from 1. Okay, this is the first point. Now what I do, that if ARRI is greater than temp underscore max. So let's say this comes out to be greater than maximum. Okay, temp underscore max. So what do I need to do? If I find something which is greater than temp max, I will change. I will say that temp underscore, okay, if I find something greater than 2, then my temp maximum will change from 2 to 8. So temp max, now let make it ARRI. Okay, and temp underscore max underscore index, make it equal to I. Okay, and it will keep on looping. So after that, if we just print temp max, once the loop is over, I see that the maximum value is 10. Okay, so what I can do later on, I can say my final max value is equal to temp underscore max and my final max underscore index is equal to temp underscore max underscore index. Okay, and now if I just print final, so let's write down the f string. The maximum value in above list is in above list slash array is so final underscore max located at index. I'll pass on the index value, so located at this index. Okay, and I close the curly braces, I close the f string literal. Now so if you see, the maximum value in above list or array is 10 located at index 10. Now let's try to test in on few other examples. So let's do, for example, I have 100, 200, let's say 150, 2001, okay, 3400, and let's say this is 4500, and let's say this is 500, this is 400, 4001, something like this. Okay, so let's say this is my index. So what is my maximum value? Maximum value is 4500, and if I run this code, it will say 4500 located at index 5. Okay, so what we did exactly, so this is the, now if you don't understand this architecture, if you don't understand what we are doing here, you will never be able to write this code. I mean, no, not even in your dreams you can write this code if you don't understand the architecture or algorithm. So this is something that you need to build. You might be hearing this type of question for the first time, but it is we are just, this is the first step. This is the first step of the bigger ladder of DSA, right? So try to grasp it, try to understand what I did exactly here, and you'll be able to understand things fairly easy in that case. Okay, so similarly we can explore a lot of things. So what we did here, we just assumed that, okay, let's say this is the maximum, and after that we tested for each, we did a linear search. Okay, if there is something value greater than this, then mark it max, otherwise move ahead, move ahead, move ahead, move ahead. So we just went from this to this only once, right? And we were able to get the value. Similarly, if someone asks you the minimum value, let's say someone asks you, tell me the minimum value in the in this particular list, so you can play around like this. So this is the whole discussion. I mean, these are a couple of practice questions, I would say, that you should solve. You can look at, I provided the solution as well, but don't look at the solution directly. I'm just giving the solution so that, because you get confused later on. So first try the questions on your own. Don't use, you can try to write the code with function, without function, that thing you can explore. Function I will start covering very soon in detail, but I've just given you some idea so that you can understand this code. But try to understand the blueprint of how I have created this particular question. So thanks again for watching this video. This was the first algorithm, and see, we have just started the first practice, like couple of practice problems we have done, total 5. There are unnumber of questions in linear search, unnumber of methods. There are like lot of good methods, good questions that we will be covering, but we need to understand these basic concepts. How do we find the maximum, how do we store, how do we search, go from left to right, those type of things you need to understand. So if you don't understand, do let me know, and let's meet in the next video. So thanks again for watching. If you like the video, please subscribe to our channel if you haven't yet, and I'm looking forward to see you in the next video. Thanks again.